Hello, Makare. I welcome you all to the Vedanta Karnataka. ನಾನು ನಿಮ್ಮ ಕೆಮಿಸ್ಟ್ರಿ ಟೀಚರ್ ರಿತಿಕಾ ಮ್ಯಾಮ್. ಸೊ ಇವತ್ತು 3 ಮಾರ್ಕ್ಸಿಂದು ಫುಲ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ತಂದಿದ್ದೇನೆ ಚಾಪ್ಟರ್ ವೈಸು ಆಯ್ತಾ. ಸೊ ಮಿಡ್ ಟರ್ಮ್ಗೆ ಯಾವ್ಯಾವ ಚಾಪ್ಟರ್ಸ್ ಇದೆ ಅಲ್ಲ ಅದೆಲ್ಲ 3 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ತಂದಿದ್ದೇನೆ ನಿಮಗೆ. ಹೋಗಿ ಇವತ್ತು ಇಫ್ ಇನ್ ಕೇಸ್ 2 ಮಾರ್ಕ್ಸ್ ಅದು ನೋಡಿಲ್ಲ ಅಂದರೆ ಹೋಗಿ ಚೆಕ್ ಮಾಡಿ. ಅವೆಲ್ಲ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸು ಎಲ್ಲ ಪಬ್ಲಿಷರ್ಸಿಂದ ರಿಪೀಟ್ ಆಗಿರೋದು, ಮಾಡೆಲ್ ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್ಸ್ನಲ್ಲಿ ರಿಪೀಟ್ ಆಗಿರೋ ಕ್ವಶನ್ಸ್ ಎಲ್ಲ ತೊಗೊಂಡಿದ್ದೇನೆ. ಸೊ ಗೋ ಚೆಕ್ ದ್ಯಾಟ್ ಔಟ್. So let me see whether I am visible and audible properly to everyone. Am I visible and audible to everyone? Yes. Okay, am I audible to visible everyone then? Hi everyone. So let's start the class then without wasting the time. So 3 marks important questions second PUC ಇದು ಯಾವ್ಯಾವ ಮಿಡ್ ಟರ್ಮ್ ಪೇಪರ್ ನಿಮ್ಮ ಪೋರ್ಷನ್ ಅಲ್ಲಿ ಇದೆ ಅಲ್ಲ ಅದರ ಪ್ರಕಾರ ಎಲ್ಲ ಚಾಪ್ಟರ್ಸ್ ಮೇಲೆ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ತಗೊಂಡಿದ್ದೇನೆ ಆಯ್ತಾ. ಸೊ ಲೆಟ್ ಸ್ಟಾರ್ಟ್. ವಾಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಒನ್ ವಿಚ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್? What is the first one which we are going to learn? That is just 1 minute. Yes, let's start with the solution chapter. That the solution first question is going to be what? Define the following terms: molarity, mole fraction, and the parts per million. I had explained this question separate video no togondidene. Go check that out everyone if you people are not seen it. Okay, so what does the define the molarity, mole fraction matte parts per million? Okay, hi everyone. So molarity andre enu? Molarity is m, which is going to be moles per or moles of a solute per liter of a solution. Per liter of a solution, that is moles per liter. That is called as what? Molarity. What is the meaning of a mole fraction? Mole fraction is going to be Na divided by Na plus Nb, number of moles of one product divided by number of moles of one more product. That is called as what? Number of moles, and that will be what? Mole fraction. Mole fraction, right? Yes. Good evening, Ananya. Good evening. Okay, next question is what? ppm, parts of a solute per million parts of a solution. Typically it is also called as what? Mg per kg for dilute solution. Clear? Next question. Give any 3 difference between solutions. And showing the positive deviation and the negative deviation from the Raoult's law. From the Raoult's law, we should show the positive deviation and the negative deviation. Okay. So what will be that? Positive means what? Positive is going to be greater than the pedal. That is going to be the delta H, means change in the enthalpy is greater than 0. That is going to be endothermic. If in case it is endothermic, means reheat is being observed from the surrounding. The heat is getting observed. That is called as endothermic process. So A minus B is going to be what? Interaction weaker than like negative pulps, which is going to be less than, and delta H mixture is going to be what? Lesser than 0. So it will be what? Exothermic. So this will be what? Exothermic process. That will be called as what? Exothermic process. So A minus B is what? Stronger than anything. So this is what you people can write it. So this is also most important questions. So na ಈಗ ಹೇಗೆ ಆಗ್ತೇನೆ ಅಂದ್ರೆ 2 ಸ್ಟಾರ್ ಹಾಕಿದ್ರೆ ರಿಪೀಟ್ ಆಗಿದೆ ಅಪ್ಪ ಒಂದು 3-4 ಸಲ ಅಂತ ಆಯ್ತಾ. ಹಾಯ್ ಗಗನ್. So in case ಏನಾದ್ರೆ 3 ಸ್ಟಾರ್ ಹಾಕಿದ್ರೆ if I will put the 3 stars, you should think like it's almost 99% fixed question. Okay, so ಆ ತರ ನೀವು ಇದನ್ನ ಮಾಡ್ಕೊಂಡು ಓದಬಹುದು. Next question is about define the term molar elevation. And the constant and the molar depression constant. Give their unit. They have asked the unit here. Yes, hi Gagan. Hi Ananya. So give their unit. They have told what will be that? Ebuloscopic constant, that is also called as Kb. This is very important, okay? Where delta Tb is going to be what? Kb into m. Delta Tb is going to be what? Kb into m. And that crystoscope, that constant is going to be considered as what? Kf. That is going to consider as Kf. Then where delta Tf is equal to Kf into m. Kf into m. Clear? Yes. So clear everyone? So what will be the unit? Kilo kg per mole. Kilo kg per mole will be its units. So ನೆನಪಿಟ್ಕೊಳ್ಳಿ solution chapter ಇಂದ numerical problem ಅಂತೂ short ಅದನ್ನ ಬಿಟ್ಟು 3 marks ಗೆ 2 marks ಗೆ theoretical questions ಕೇಳ್ತಾರೆ. Theory means direct question ಕೇಳೋದು. So ಈ question ಭಾಳ ಸಲ repeat ಆಗಿದೆ. Unit ಬಗ್ಗೆ, definitions ಬಗ್ಗೆ ಆ ತರ questions ಭಾಳ ಸಲ repeat ಆಗಿರೋ questions. So I will put it as 2 stars. Clear? Next question. Question, give any 3 difference between solution showing positive deviation. The solution which is showing what? Positive deviation, and the next one is negative deviation from the Raoult's law. From the Raoult's law. Now positive means what? Pops. This is greater than what? Pedal. Then delta H mixture is going to be what? Delta means change in H is going to be greater than 0. If it is greater than 0, it will be what? It will be endothermic. Means endothermic means it's going to observe the heat from the surrounding. That is going to be observe the heat from the surrounding. A-B interaction is going to happen, which is going to be weaker than like, and negative forms which is going to be lesser than the pedal. That is going to be the exothermic. Next question is what? Define the term molar elevation constant and molar depression constant. This also has been asked a lot of times. Okay. Next, what is an isotonic and hypertonic and hypotonic solution? See, this is also very important. These definitions have been asked a lot of times. So I'm putting it as 3 stars. 3 stars means what? It's definite question. Okay. Isotonic solution andre enu? Which have a equal osmotic pressure. Which has what? Equal osmotic pressure. And hypertonic has what? Higher osmotic pressure. Higher osmotic pressure than the reference, which is causing the solvent to flow out of the cell. Flow out of the cell means what? Isotonic solution is having equal to the osmotic pressure, and the whatever the hypertonic solution is there, that is higher osmotic pressure it is having, then compared to the reference to the causing the solvent to flow out of the cell. So that hypotonic is what? Hypotonic has the lower osmotic pressure and solvent flows into the cell. Solvent will flow into the cell. This is out of the cell. What happens in the hypertonic? Hypertonic out of the cell. Hypotonic inside the cell. It's going to work inside the cell. Clear? Next question. With the help of the vapor pressure, temperature diagram, explain the elevation in the boiling point. Explain the elevation in the boiling point of a non-volatile solute. Of a non-volatile solute. Of a in volatile solvent, how would you determine molar mass of a solute using the above property? Using the above property. Solute lowers the solvent pressure. Solute lowers the solvent pressure. So the temperature at which vapor pressure equals to the external pressure, also starts increasing. External pressure also starts increasing there. Then afterwards the boiling point elevation will be also increasing. Boiling point elevation also starts increasing. So from delta TB is equal to KB into M, find the molarity of M, that is going to be delta TB divided by KB. Then what happens to the molar mass? Molar mass is equal to mass of a solute, that is going to be divided by M into kg solvent. M into kg solvent. ಈ ಡೆಫಿನೇಷನ್ ಅನ್ನು ಬರೀಬಹುದು. ಆ ಡೆಫಿನೇಷನ್ ಆದ ತಕ್ಷಣ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮ್ ಅನ್ನು ಬರೀರಿ. ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮ್ ಬರೆದ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ. ಯಾರು ಚೆಕ್ ಮಾಡ್ತಿರ್ತಾರಲ್ಲ ಪೇಪರು ಅವ್ರಿಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಈಸಿಲಿ. ಏನಪ್ಪ ನೀವು ಕ್ಲಾರಿಟಿ ಆಗಿ ಡೆಫಿನೇಷನ್ ಏನು ಬರ್ದಿದ್ದೀರಾ ಅನ್ನೋದು ತಿಳಿತಾ? Next one, what is a reverse osmosis? Mention one of the practical uses. So this is also very important, guys. This has repeated a lot of times. Okay. So and give an example from a artificial semi-permeable membrane. Now forcing solvent forcing the solvent from the solution to pure solvent side through the semi-permeable membrane. Through the semi-permeable membrane by applying the pressure greater than the osmotic pressure. Greater than the osmotic pressure, which is used for the distillation of a seawater. Which is used for the distillation of a seawater. You should remember one important thing here. What is that important thing? If in case they are telling the reverse osmosis, you should think that whatever the osmotic pressure is being used, this is used in the distillation of a seawater. Okay, distillation of a seawater, that you should remember. Example in ತಗೋಬಹುದು cellulose acetate or polyamide thin film compost. That is going to be the example. So ee tara question ಕೇಳ್ತಾರೆ osmotic pressure ಬಗ್ಗೆ ಆಯ್ತಾ. So osmotic pressure, reverse osmosis and define its practical uses. Okay, this is also asked a lot of times. Make sure you people will practice this question properly. Next, non-ideal solutions exhibit either positive or a negative deviation. Okay, ಯಾವ್ದಪ್ಪ ಆಗುತ್ತೆ at least positive ಆಗುತ್ತೋ negative deviation ಅನ್ನು form ಆಗುತ್ತೆ Raoult's law ಅಲ್ಲಿ. Which is Raoult's law ಅಲ್ಲಿ. In Raoult's law, why are these caused and explain with the suitable example of each type. Suitable example of each type. Deviations arise from unequal AB interactions. Unequal AB interactions. And this versus A and B, whatever it is there, that positive deviation when A and B is weaker. Example, ethanol plus cyclohexane. If in case A and B, when the ethanol A anta tilkoli, B and the hexanol anta tilkoli. Avu eradu react adre enappa agutte. If those both will get reacted, these will give higher vapor pressure. That will give what? Higher vapor pressure. If ethanol and the cyclohexane, that is A and B, both will get reacted, then we will get it as what? Higher vapor pressure. Clear? So, this higher vapor pressure bandre, if in case that is positive. Now, negative when A and B is there. Okay, negative. That is going to be stronger one. If in case we are taking the example has acetone and the chloroform. Okay, acetone ಮತ್ತೆ chloroform ಅನ್ನ example ತಗೊಳ್ಳೋಣ. Okay, same ಹೇಗೆ ನಾವು AB ಗೆ ethanol ಮತ್ತೆ cyclohexane ತಗೊಂಡಿದ್ವಲ್ಲ, same ಅದೇ ತರ when it is a negative. Okay, when it is a negative, ಆವಾಗನು A ಅನ್ನ ಏನು ತಗೊಳ್ಳೋದು? acetone ಅಂತ ತಗೊಳ್ಳೋದು, B ಅನ್ನ chloroform ಅಂತ ತಗೊಳ್ಳೋದು. And which was giving what? Lower vapor pressure. Which is giving what? Lower vapor pressure. Clear everyone? You should say yes in the chat box, then only I'm going to get it. Next question is what? Give an example of ideal solution and one of the non-ideal solution with positive deviation. With positive deviation. Positive deviation ಇಂದ ಏನಪ್ಪ ಆಗುತ್ತೆ? Consider ಮಾಡಿ. Ideal ಏನಾಗುತ್ತಪ್ಪ? N hexane. ಇದು N hexane ಏನಿದೆಯಲ್ಲ plus N heptane approximates ideality. And what happens with the positivity? Here you can check. Positivity, whatever it is there. One second. Yes, whatever the positive is there, positive deviation, there the ethanol plus the acetone or the carbon tetrachloride plus the benzene. Carbon tetrachloride plus the benzene is the option we can tell. Yes, Gagan, understanding? Everyone needs to tell yes in the chat box, then only I'm going to get it. So, ಏನು ಹೇಳಿದಾರೆ ಇಲ್ಲಿ example, you ಹೇಳಿದ್ರಲ್ಲಿ ಅಂತ ideal ಮತ್ತೆ non-ideal solution ಮೇಲೆ sure question ಬೀಳುತ್ತೆ. Make sure ideal ಮತ್ತೆ non-ideal solution ಮೇಲೆ ಯಾವ್ಯಾವ ಕ್ವಶನ್ಸ್ NCERT ನಲ್ಲಿ ಇದೆಲ್ಲ ಅದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಈ ಕ್ವಶನ್ಸ್ ಮಾಡೋದಂತೂ 100% ಮಾಡಿ, ಮಿಸ್ಸೇ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. 100% ಶಾರ್ಟ್ ಕ್ವಶನ್ಸ್ ಬೀಳುತ್ತದು ಆಯ್ತಾ. Give an example of an ideal solution and one of the non-ideal solution with a positive deviation. So what happens if there is positive deviation? The ideal will be 1 hexane plus the 1 heptane approximates. Okay, approximates the ideality. If in case we are taking the positive deviation, what happens in the positive deviation? In positive deviation, if we are taking ethanol, okay, ethanol where it is reacting with the acetone or carbon tetrachloride plus the benzene. Clear? So next question. What are the conditions for the ideal behavior of the solution? Why do the vapor pressure of the solution deviate from Raoult's law? Which will deviate from the Raoult's law? Concentrate. This is also a very important question. Okay. Next, ideal, when it is ideal, it's going to be what? Delta H is going to be 0 and delta V mixture is going to be also 0. Okay. And what happens with the AB interactions? Whether we are taking a negative, positive, that is different, but we should take it in a form of what? tell me in Kannada, ma'am. I'm telling it in Kannada only, Gagan. So whatever A and B interaction in and A and B interaction, that will be equal to like pairs. Like the pairs across all the composition, like the pairs across the all composition. Yavadu A B nalli in case negative tagondvi papa positive tagondvi yavdu tagondvi ಏನು option ಇಲ್ಲ. Okay, so positive tagondre different reaction ಆಗುತ್ತೆ, negative tagondre different types of reaction it will become in a Raoult's law. ಆಯ್ತಾ? So in a Raoult's law same thing it is happening here also. ಇಲ್ಲಿ derivation ಆಗಿಲ್ಲ, deviations occurs because AB interaction is differing. It's actually getting differing. AB interaction is getting differed. Why it is getting differed? Whether we are going to take negative or a positive, that matters a lot. Now alternating escaping tendency, that is vapor pressure. Clear? Next question. Derive the relationship between vapor pressure lowering and a mole fraction of a solute. What is azeotropic mixture? What is azeotropic mixture? Give example. Give example. Come on, let's answer this. For a dilute solution, if in case we are taking a dilute solution, what will happen? Delta P is equal to P naught A minus PA. That also can be written as what? P naught A into XB, where it's going to be relative. It's going to be the relative lowering of delta P divided by P naught A is equal to XB. Delta P naught divided by P naught A, that is going to be the XB. So if in case that we are going to take it, then what happens with the NB? NB is divided by NA plus NB, number of moles of A and number of moles of B. Okay. So what happens with the azeotrope boils? When the azeotrope is going to boil at a constant composition, due to the minimum or maximum in total pressure, so that time it's going to be like it starts boiling. Azeotrope will start boiling at any minimum or a maximum trashing. Okay, any minimum or a maximum pressure. Example, what we can take it? Ethanol, water, that is also going to be what? 95% of azeotrope. 95% of azeotrope. Understanding? Yes, let's move to the next question. Why do electrolytes show abnormal molecular masses? Why do electrolysis yakappa abnormal molecular masses in a form madutte? Name the factors which is responsible for the abnormality. Okay, yaad responsible ide abnormality ge. Okay, so enagadappa electrolytes which will dissociate into ions in an increasing number of solute particles, which is giving the higher colligative effect. Which is giving what? Higher colligative effect, and the lower apparent molar mass, degree of dissociation and the ion pairing activates are responsible. It will start activating the things here. How it will start activating? This dissociates into the ion, which will increase the number of the solute particles. Solute particles ಜಾಸ್ತಿ ಆಗುಂತ ಹೋದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? Dissociate, degree of dissociation will start forming a ion pairing. It will start forming a ion pairing. Next, the vapor pressure of a pure liquid A is 40 mm and mercury at 310 Kelvin. So the vapor pressure of this liquid in solution B is 32 mm mercury. If the mole fraction of A in the solution is 0.8, the solution obeys the Raoult's law. Show the calculation they have told. Such type of a calculation also they will be asking it. Calculations are very important. So most probably numerical problems 5 marks ಗೆ ಕೇಳೋದು, 3 marks ಕೇಳೋದು ಬಹಳ ಕಡಿಮೆ. ಡೈರೆಕ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳಿದ್ರೆ ಕೇಳಬಹುದು 3 marks ಗೆ. ಓಕೆ, ಸೊ 3 marks ಗೆ ಡೈರೆಕ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳಿದ್ರೂ ಕೇಳಬಹುದು. One second. Direct question ಕೇಳಿದ್ರೂ ಕೇಳಬಹುದು. Next chapter is about the electrochemistry. Okay, electrochemistry ಇದೆ, chemical kinetics ಇಲ್ಲ ನಿಮಗೆ, electrochemistry chapter ಅಷ್ಟೇ ಇರೋದು. ಅದಾದ ತಕ್ಷಣ ಎಲ್ಲ ಆರ್ಗ್ಯಾನಿಕ್ ಆಯ್ತಾ. How much charge is required for the following reduction? First one is what? 1 mole of Al3 to Al. 1 mole of Al3 to Al. So what they have told it? First one, if in case charge Q is going to NF, that you people know, per mole. Okay, this at least we know. Charge Q is actually equal to NF. In detail, I already explanation kottide nanu. Go check it out in our channel itself. Okay. So first one in case idin formula use ಮಾಡಿ ನೀವು ಅದನ್ನ ಆನ್ಸರ್ ಫೈಂಡ್ ಮಾಡಬೇಕು. ಓಕೆ, ಫಸ್ಟ್ ಒನ್ 1 mole of Al3 plus to Al means 3 plus ಇಂದ 1 plus ಗೆ ಆಗ್ತಿದೆ, ಡೊನೇಟ್ ಆಗ್ತಿದೆ, 3 electrons ಕೊಡ್ತಿದೆ. ಹೇಗೆ ಮೈನಸ್ ಆಗ್ತದೆ, ರಿಡಕ್ಷನ್ ಹೇಗೆ ಆಗ್ತಿದೆ ಅನ್ನೋದು ನೋಡೋದು. So 3s is equal to what? 3 into 96485 coulomb, that we know what already. 6.89 into 10 raised to 5 coulomb. How much it will be? 2.89 into 10 raised to 5. This will be the answer for this. Next one is what? 2f. If in case it is a 2f, then what will be that? That is going to be 1.93 into 10 raised to 5 coulomb. 10.10 raised to 5 coulomb. If in case, third one is 1 mole of MnO4 minus to Mn2 plus. Mn2 plus. ಇಲ್ಲಿ ಏನಾಗಿದೆ 4 minus ಇಂದ 2 plus ಗೆ ಹೇಗೆ ಆಗ್ತಿದೆ ಅಪ್ಪ ಕೇಳಿದ್ದಾರೆ. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, acidic MnO4 minus plus 5 electrons means what? 5 electrons is been giving. 5 electrons are been giving to them. Then what will be that? 4.82 into 10 raised to minus 5 coulomb. So it will be how much? 4.82 into 10 raised to minus 5 coulomb. Next question. One second. Yes. Describe the construction and working of SH, standard hydrogen electrode. Standard hydrogen electrode. This is very, very important, guys. This is gonna fall a lot of times. Balasala repeat agide, right? So platinized PT electrode, 100% sure we need to take a platinized PT electrode itself, which is being painted from the black color. Why? Because usually that will be more effective than the other metals. Okay. So platinized PT electrode immersed in 1 mH plus solution with H2 bar at 1 bar bubbling over it. Half reaction 2H plus, which is going to get reacted with 2 electrons to form what? H2 gas. It is going to form what? H2 gas. So now this is going to be assigned. This will be assigned to what? E naught is equal to 0.000 volt. If in case now 0.000 volt ತಗೊಂಡ್ವಿಯಪ್ಪ, okay, at 298 Kelvin, at the temperature of how much? 298 Kelvin. What will be used? This will be used as a reference to the measure electrode potential, which is reference to the electrode potential. Clear? So ee tara questions annu bala sala kelidare. SH ಬಗ್ಗೆ 100% sure. Okay. What is electrochemical series? What is electrochemical series? What are its applications? What are its applications? Now, table of a standard reduction potential arranged in an order of applications include predicting the spontaneity and the EMF of a cell and that relative oxidizing or reducing strength, flexible displacement reactions, and corrosion or a metal extraction tendencies. This also can be answered there. Next question is what? Give reason. Give reason question into 100% sure. Make sure to sit and learn the give reasons properly, everyone. Okay. Give reasons. You people need to learn it properly, everyone. Clear? Check this out, everyone. Check this, everyone. Yes. So give reason is what? Zn displaces Cu from, Zn is actually displacing the Cu from CuSO4 solution. From CuSO4 solution. Second one is what? Zn displaces from H2 from HCl. H2 HCl H2 ಹೋಗುತ್ತೆ, displace ಆಗುತ್ತೆ, ಮತ್ತೆ copper ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? copper sulfate ನಲ್ಲಿ copper solution ನಲ್ಲಿ completely Cu ಹೋಗುತ್ತೆ. Clear? So afterwards what is going to happen here? Fe will displace Cu from CuSO4, but this Cu cannot displace Fe from FeSO4. Why? That is the give reason which you people need to understand. See the answer now. Metals higher in the series, that is more negative E naught, are stronger reducing agent. These are what? Stronger reducing agent. And this E naught, that is Zn2 plus or Zn, which is being taken, which is less than, okay? Which is less than, okay? This is very important. Less than E naught Cu plus TCu. Mandre Cu copper 2 electrons inu copper ಕೊಡ್ತಿದೆ, copper ಕೊಡ್ತಿದೆ 2 electrons ಅನ್ನು, ಆಯ್ತಾ? So ಅವಾಗ ಏನಾಗುತ್ತೆ? Zn will reduce. That is going to be what? Cu2 plus E naught will be less than E naught 2 plus 2 plus. Theta hydrogen ge 2 kodtide. So idನ್ನ ಕಡಿಮೆ ಆಗೋತ್ ಹೋಗುತ್ತೆ. Z E naught value ಕಡಿಮೆ ಆಗುತ್ತೆ. ತಿಳಿತಾ? Next one ಏನಾಗುತ್ತಪ್ಪ? So what happens? Zn will liberate the H2 gas. For that only Zn is liberating the H2 gas here from the HCl. That is what the reason is. We are giving the reasons here because they have asked the give reason to us. But if in case E naught, that is Cu2 plus 2 or Cu, which is actually greater than the E naught, here what happens? This 2H plus, so the copper does not. Does not. Now what happens here? Very important. This E naught which is present, that is going to be the less than the copper. So Fe will displace the copper reverse, not the visible. Reverse but not the visible. This is very, very important, guys. This has been repeated a lot of times. Make sure you people will practice that very nicely. Okay. Next question, write a neat diagram of a H2O2 fuel cell and express as in the cathodic and the anodic reaction. You people can draw the diagram. This also has been asked. Okay, 3 marks usually kelala. Ondansala 3 marks keltare, ondansala 5 marks ganu kelbodu. Next question is what? Explain the corrosion is an electrochemical phenomenon. It is an electrochemical phenomenon. Rusting involves anodic dissociation of iron. That is going to be what? Fe. It is getting converted to Fe2 plus 2 electrons. Clear? Plus 2 electrons. Then at one reason and cathodic oxygen reduction, that is going to be O2 plus 2H2O plus 4 electrons. That is forming what? 4OH. First one yadappa? Fe2 plus manse 2 electrons ಕೊಡ್ತಿದೆ. ಆಮೇಲೆ ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಏನಾಗುತ್ತೆ? O2 plus 2H2O 4 electrons ಕೊಡ್ತಿದೆ OH ಗೆ. 4 electrons are giving for the OH. Clear? So at another, with an electrolyte film enabling the ionic or electron flow is happening. Thus an electrochemical cell operates on the metal surface. It will operate from the metal surface. Clear? So the such questions also on the corrosion also they will ask the question. They might ask it for the MCQ also. Corrosion question MCQ ನಲ್ಲಿ ಜಾಸ್ತಿ ಕೇಳಿದಾರೆ. ಅದನ್ನು ರಿಪೀಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. In case MCQ questions ಅನ್ನು ನಾ ಮಾಡ್ತೇನೆ. ಅದರಲ್ಲಿ ನೋಡ್ಕೋಬಹುದು. ಆಯ್ತಾ? Next is what? Write the cathodic and the anodic reaction of a lead storage battery at both the discharge and the recharge process. Discharge and the recharge process. Now what happens at the discharge? At a discharge, this anode which is present, that is Pb, is getting reacted with SO4 2 minus. SO4 2 minus to form what? PbSO4 plus 2 electrons. PbSO4 plus 2 electrons. Clear? So discharge ಆಗೋ ಟೈಮ್ದಲ್ಲಿ, okay? Discharge ಆಗೋ ಟೈಮ್ದಲ್ಲಿ cathode ನಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ? This PbO2 plus hydrogen, 4 hydrogen atoms which is getting reacted with SO4 2 minus plus 2 electrons. It's going to be forming what? Concentrate here PbSO4 plus 2H2O. PbSO4 plus 2H2O. This is anode one processor, cathode one processor. This overall again agate Pb is equal to PbO2 plus 2H2SO4 which is going to form what? 2PbSO4 plus H2O plus H2O. This is the overall reaction of an anode and cathode. Clear? Next, recharge the reverse these reactions to regeneration of the Pb and PbO2. Okay, we should reverse back it to recharge it. Okay, that's the answer. Next question is what? State the Goelz law and what are its application. Sure, short question, guys. Sure, short question, no? Considered ಮಾಡಿ. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? At infinite dilution, the molar conductivity of an electrolyte equals to sum of independent ionic conductivities. Like what? Delta M infinite is equal to delta plus infinite plus delta minus infinite. Delta is infinite. Now these applications will include what? Calculating the infinity and the weak electrolytes, determining the degree of dissociation and estimating the Ka as a weak acids or a base. In this way you can mention it, or else you can write the law and its application you can write in the point wise also. Point wise agi applications ana baribodu, 2 ಇಂದ 3 ಪಾಯಿಂಟ್ ನೀವು ಹಾಕಬಹುದು. ಆಯ್ತಾ? ಸೊ ಈ ತರನು ಬರ್ಕೋಬಹುದು. Next question is give the products obtained at each electrode respectively when molten NaCl. When molten NaCl is present, aqueous NaCl and acidulated H2O, which is undergoing the electrolysis. Which is undergoing what? Electrolysis. Now consider here the molten NaCl, which is going to be the cathode. Okay, which is going to be the cathode, that is Na. Anode is going to be what? Cl2, which is going to be the Cl2. Now that aqueous NaCl, which is cathode, that is H2, anode, which is Cl2, which is going to act like a Cl2. Anode is Cl2, cathode is H2. Consider it properly. Cathode andre H2, anode andre Cl2 ತಗೊಂಡಿದ್ದೇವೆ. Okay. Continue. If in case O2 is independent, depending on the conditions, like commonly Cl2 ಗೆ depend ಆಗಿದೆ O2. Okay. ಅವಾಗ ಏನಾಗುತ್ತೆ? Acidulated water, that is cathode H2 is going to be and anode is going to be the O2. In this way, you people need to solve it. Okay. ಯಾವ product obtain ಆಗುತ್ತೆ ಅನ್ನೋದು electrode ನಲ್ಲಿ respectively, if in case they have taken a molten NaCl at a aqueous, yes, aqueous NaCl. Clear? Next question. State the Faraday's first and the second laws of electrolysis. Give mathematical expression. This is short guys. 100% short question. Okay. So state Faraday's law. First one in Bharatappa. That is mass deposited. That is M is directly proportional to the total charge Q, and M is equal to QM into the divided by NF, and second is going to be what? For the same charge, masses are proportional to equivalent masses. M is directly proportional to M by N. M is directly proportional to M by N. That is called as Faraday's first law and the second law description. Next one, write the note on a dry cells and the mercury cells. Dry cells and the mercury cells. Most probably they will ask it 2 or 3 marks. Sure question. Okay guys. See, ಯಾವ sure question ಹಾಕಿದೇನಲ್ಲ ಅವನ್ನೆಲ್ಲ 100% ಬೀಳುತ್ತೆ. So electric by dry cell, that is also called as Zn anode, that is going to be MnO2 divided by C, that is going to be the cathode, with NH4Cl ZnCl2, which is going to be the paste of how much? 1.5 volt primary cell. Then mercury cell is going to be what? Zn, zinc and mercury. That is going to be an amalgam anode, and there HgO, which is going to be the cathode in a KOH divided by ZnO paste. This is going to be what? 1.35 volt flat. 1.35 volt flat discharge used in a electrolyze, and the now limited due to the mercury toxicity. Mercury toxicity salvagi concentration change ಆಗುತ್ತೆ. ಅದರ ಪ್ರಕಾರ dry cell ಮತ್ತೆ mercury cell work ಆಗೋದು. ಆಯ್ತಾ? Next question. Okay, this is at least short question guys. ಅದರ ಮೇಲೆ 3 marks ಬಿದ್ರು ಬೀಳಬಹುದು. Nernst equation ಬಗ್ಗೆ ನಾನಂತೂ ಆಲ್ರೆಡಿ ಹೇಳಿದೆ, KCET ನಲ್ಲಂತೂ short. Even in this also, it's a completely a short question. Okay, it's completely a short question. Consider here, write the Nernst equation and EMF of the following cells at 298 Kelvin. At 298 Kelvin. First one, what they have asked, they have given all the equations here properly. We need to find the Nernst E0 cell. Means we need to find the E cell is equal to E0 cell minus 0.0591 divided by N log of Q. By using this formula, we need to find the other things. All 4 they have given it. You can check it out properly, everyone. ಇದನ್ನು ಒಂದ್ಸಲ ಚೆಕ್ ಮಾಡ್ಕೊಂಬಿಡಿ ಕ್ವಶನ್ ಅನ್ನ. ಆನ್ಸರ್ಸ್ ಅನ್ನು ಆಲ್ರೆಡಿ ಕೊಟ್ಟಿದ್ದೇನೆ. ಸೊ ನೀವು ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಈ ತರ ಕ್ವಶನ್ಸ್ ಭಾಳ ರಿಪೀಟ್ ಆಗುತ್ತೆ. ಆಯ್ತಾ? ಸೊ ನರ್ಸ್ ಇಕ್ವೇಶನ್ ಕೊಡ್ತಾರೆ, EMF ಆಫ್ ದ ಸೋಲ್ ಫಾಲೋವಿಂಗ್ ಸೆಲ್ ಕೊಡ್ತಾರೆ. ನಾವು ಈ ಫಾರ್ಮುಲಾನು ಹಾಕಿದನಲ್ಲ, ಈ ಫಾರ್ಮುಲಾನು ಯೂಸ್ ಮಾಡಿ ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಒನ್. Okay, next chapter is what? D and F block elements. From D and F block elements, concentrate. Write the balanced chemical equations for the reactions involved in preparation of potassium permanganate. Preparation of potassium permanganate from MnO. Magnesium oxide. Adrinda preparation ಮಾಡಬೇಕು. Write the structure of magnate ion. Where the structure of a magnate ion. And what is going to be fusion? Now if in case we are taking MnO2, which is getting reacted with KOH plus O2, which will form what? That is 2K2Mn4 plus 2H2O plus the 2H2O. Clear? Understanding this? This is very important question. Balance ಮಾಡೋದು ಬಹಳ important question. ತಿಳಿತಾ? Yes. So the disk proportionality ಏನಾಗುತ್ತಪ್ಪ on high oxidation or alkaline to the neutralization ಗೆ ಏನಾಗುತ್ತೆ ಅವಾಗ K2MN4 sorry K2MN4 okay 3K2MN4 plus 2H2O which will form KMNO4 plus MnO2 plus 4KOH by what? By Cl2O3 by Cl2O3. This is how the reaction is going to form. Oxidation of MnO2 2 minus. Clear? So structure ಏನಾಗುತ್ತಪ್ಪ MnO2 which is a tetrahedral with the Mn. Tetrahedral with the Mn. Tetrahedral structure ಅನ್ನ ಇರುತ್ತೆ. Next question, write the balanced chemical equation for the reaction involved in the preparation of potassium dichromate. Ali potassium K2MO potassium permanganate ittu. Illi dichromate from the chloramite ores. Okay, ಇಲ್ಲಿ just difference ಇದೆ ಬರೆ balanced chemical equation ಅಂತ ಕೊಡ್ತಾರೆ just preparation little bit of difference is there. Okay, ಅಲ್ಲಿ potassium permanganate ತಗೊಂಡಿದ್ರು ಇಲ್ಲಿ potassium dichromate ತಗೊಂಡಿದ್ದಾರೆ. Okay, ಇದು ಒಂದ್ಸಲ important question. Okay, next roasting, that is 4FeOCr2O3 plus which is getting reacted with 8Na2CO3 plus 7O2 which will form what? 8Na2CrO4 plus 2Fe 2Fe2O3 and 8CO2 which is actually a conversion to 2Na2CrO4 plus H2SO4 which is forming what? Na2Cr2O7 Na2Cr2O7 form ಆಗುತ್ತೆ ಆಮೇಲೆ Na2SO4 plus H2O is going to form means what? Crystallization with the KCl what we will get? Na2Cr2O7 plus KCl plus it is going to form K2Cr2O7 and 2NaCl. Clear? So, ee tara questions annanu keltare. Understood? Next question. Write the balanced chemical reaction for the following. That is K2Cr2O7 with iodine ion in the acidic medium anta kelidara. Second one K2Cr2O7 with a sulfide ion in the acidic medium. Okay, ಎರಡು acidic medium ನಲ್ಲಿ. Third one in ಕೇಳಿದಾರಪ್ಪ K2Cr2O7 with the stannous ion same acidic medium ನಲ್ಲಿ. Okay, first one in ಹೇಳಿದಾರೆ K2Cr2 with iodine ion ನಲ್ಲಿ react ಆದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ 6 iodines ತಗೊಂಡಿದ್ದಾರೆ ಏನು ಫಾರ್ಮ್ ಆಗುತ್ತೆ 2Cr3 plus 7H2O plus 3 iodine when it will react with the iodine. Second one with the sulfide ion. Second one is sulfide ion inda. So K2Cr2O7 ತಗೊಂಡ್ರೆ sulfide ion ಇಂದ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ತಕ್ಷಣ 3 sulfide ions they have taken it with 14 hydrogens. What's going to form 2Cr3 plus 7H2O plus 3 sulfide. Clear? So this is how the reaction is going to form. Last one here there is same K2Cr2O7 ದಿಂದ stannous ion in the form ಮಾಡಿದ್ರೆ acidic medium ನಲ್ಲಿ ಏನಪ್ಪ ಆಗುತ್ತೆ when it will react with the same thing just we are taking the stannous ion here that is 3SN2 plus so ಏನು ಫಾರ್ಮ್ ಆಗುತ್ತೆ 3SN4 plus 3SN means 2 electrons gain ಆಗುತ್ತೆ means ಇನ್ನ 2 electron ಕೊಡುತ್ತೆ 2 electrons will be given to someone. Next, write a balanced chemical equation or a reaction for the following. First one KMNO4 with iodine ion in acidic medium. Same again with the KMNO4 with the iodine ion in a neutral medium. Then in the acidic medium. ಯಾವ medium ಕೇಳಿದರೆ acidic medium, neutral medium ಮತ್ತೆ acidic medium. ತಿಳಿತಾ? Okay. So let's start. First one is what? KMNO4 with the iodine ion. So ಇಲ್ಲಿ iodine 10 iodines ತಗೊಂಡಿದ್ದಾರೆ, right? 16 hydrogen ಜೊತೆ react ಆಗಿದೆ, right? So what will be forming here? 2Mn2 plus 8H2O which is forming 5 iodines. That is 5I2 is getting formed here. Second one is what? MnO4 which is getting reacted with the iodine again with the water to form what? Overall balanced chemical equation is going to form what? Iodine. One iodine react ಆಗುತ್ತೆ H2O ಜೊತೆ. Okay, H2O ಜೊತೆ react ಆಗುತ್ತೆ ಏನಪ್ಪ ಫಾರ್ಮ್ ಆಗುತ್ತೆ 2MnO2 plus IO3 plus OH. This is under mid basic or a neutral acceptance of a MnO2. Neutral acceptance of a MnO2. Aita? So paths vary and the standard school form gives as MnO2 and IO has a IO3. Okay. So last one ಏನು oxalate ion ಇಂದು acidic medium ನಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. Oxalate ion ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ 2MnO4 which is getting reacted with 4C2O4 5C2O4 minus means 2 electrons gain ಆಗ್ತಿದೆ. ಓಕೆ, ಮತ್ತೆ 16 ಹೈಡ್ರೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿದ ತಕ್ಷಣ 2MnO2 10CO2 plus 8H2O. Clear? Next, this is also a direct question. What are interstitial compounds? Write any two properties of it. Very important question, guys. Okay. Next, non-stereochemistry compounds formed when small atoms like H, hydrogen, boron, carbon, nitrogen, such compounds when we take, which will occupy interstitial sites in the metal lattice, these properties had the high melting point, often retain metallic conductivity and shows the chemical inheritance. Chemical inheritance will be shown there. Clear? So, next question, write the composition for the following: UK copper, silver QK coins and Ziegler catalyst. So, these are the three composition which they have given. They told us to write the composition for those three elements or three compounds we can tell. Okay. First one UK copper. UK copper which is copper which is coated with the steel, that is steel core with a copper plating, that if in case copper neon alloy, that is CuNi alloy, that is coponickel is going to be formed. Third one is a question of Ziegler catalyst. So here what happens, the triethyl, okay, triethylamine with a TiCl4 which will be formed what? AlC2H5 3 TiCl4 which is used for what? Polymerization. This Ziegler catalyst is actually used for what? Polymerization ge use martare. Next one, name the catalyst which is used in the following, like Haber process, Vasker process, hydrogenation of oils. First one is what? Finely divided Fe with K2O or Al2O3 promoters. Like this is the example which we can give it for what? Haber process. Okay, Haber process equation la kodabodu. This is also very important, guys. Okay, repeated question. Okay. Next, PDCl2 or CuCl2 catalyst system for what? Vasker process. Okay, named reactions. So named reactions are very, very important. Okay, hydrogenation of oil. So Ni, that is Rani-Inkel or PT or PD anta yavdo ಒಂದು element ಅನ್ನು ತಗೋಬಹುದು. Last question, write the this question, write the products formed when the lanthanides react with carbon, nitrogen and acids. Okay, ಯಾವಾಗ lanthanides carbon ಜೊತೆ react ಆಗುತ್ತೆ, carbon ಜೊತೆ react ಆದ್ರೆ ಏನಾಗುತ್ತೆ form ಆಗುತ್ತೆ? Carbides such as LnC2 or LN2C3 or LN2C3 ಇದನ್ನ form ಮಾಡುತ್ತೆ. If in case nitrogen ಜೊತೆ react ಆದ್ರೆ ಏನಾಗುತ್ತಪ್ಪ? LN. Okay, LN form ಆಗುತ್ತೆ. If in case ಇದು acid ಜೊತೆ react ಮಾಡಿದ್ರೆ with the dilute acid it gives Ln3 plus salts liberating the H2 gas. Ln3 plus gas release ಆಗುತ್ತೆ plus H2O ಜೊತೆ H2 gas ಜೊತೆ. Clear? Next one, give reasons for the following. First one here, actinides showing the higher oxidation state. Actinides showing the higher oxidation state. If in case they are showing the higher oxidation state, participation of 5F, 6D, 7CF electrons enables the wide range of a state up to where? Up to +6 to +7 oxidation state. +6 in the +7 oxidation state in the form ಮಾಡುತ್ತೆ. B, 5F orbitals shelled properly means astenoid's contraction is greater than the element 2B element than lanthanoid contraction. So this 5F orbitals will shed poorly, leading to the stronger contraction than 4F. Stronger contraction than the 4F. Last one, chemical properties of the actinoids are less known. So itradu yallakna kadame known iddudu yakappa. So most actinoids, whatever the actinoids are there, they are radioactive, scarce and difficult to handle and limiting schematic study. So this means what? It is very radioactive. Okay, asteroids alla radioactive irutte. Radioactive andre use madlikke bhala difficult to store madlikke bhala difficult to adar salavagi use ಮಾಡೋದನೆ ಕಡಿಮೆ. ಅದು ಯೂಸ್ ಮಾಡೋದು ಕಡಿಮೆ ಆದ ತಕ್ಷಣ ರಿಯಾಕ್ಷನ್ ಆಗೋದನ್ನು ಕಡಿಮೆ ಆಗುತ್ತೆ, because we are not using those elements in the different things. Clear up? Next, the transition metals from the large number of complex compounds give 3 reasons. So whatever the transition metals are there, adardu large number of complex compounds, so adardu 3 reason anna kodbeku. So in case if it is a small highly charged cations with the vacant d orbitals for the coordination, variable oxidation states, stabilizing different complex ion, high CFSE with diverse geometrics and ligand types enabling the chelation and the stability. This is actually called as what? The transition metals from the large number of complex compounds. These are the 3 reasons why it has been forming. Means this is also small type of a give reason. Okay, such questions also will be asked. D and F block in the give reason type of questions ಜಾಸ್ತಿ ಕೇಳ್ತಾರೆ. ಯಾಕಂದ್ರೆ ಎಕ್ಸೆಪ್ಷನಲ್ ಜಾಸ್ತಿ ಇಲ್ಲಿ ಡಿ ಅಂಡ್ ಎಫ್ ಚಾಪ್ಟರ್ ಇಂದ ಎಕ್ಸೆಪ್ಷನಲ್ ಜಾಸ್ತಿ ಅಂದ್ರೆ ಏನೋ ಒಂದು ನಡೀತಿರುತ್ತಪ್ಪ. ಓಕೆ, ಡೌನ್ ಟು ದ ಗ್ರೂಪ್ ಅಟಮಿಕ್ ಸೈಜ್ ಇಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್, ನಂಬರ್ ಇಸ್ ಇನ್ಕ್ರೀಸ್, ಸಮಥಿಂಗ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ದರ್. ಓಕೆ, ಬಟ್ ಒಮ್ಮೆ ಮಿಡಲ್ ಆಗಿ ಏನಾಗುತ್ತೆ, ಇದು ವರ್ಕ್ ಆಗಲ್ಲಪ್ಪ, ಈ ಎಲಿಮೆಂಟು ವರ್ಕ್ ಆಗಲ್ಲ, ಇದು ಇನ್ಕ್ರೀಸು ಆಗಲ್ಲ, ಡಿಕ್ರೀಸು ಆಗಲ್ಲ, ಆ ತರ ಎಕ್ಸೆಪ್ಷನಲ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಓಕೆ, ಸೊ ಫಾರ್ ದಟ್ ಪರ್ಪಸ್ ಗಿವ್ ರೀಸನ್ಸ್ ಆರ್ ಮೋರ್ ಆಸ್ಕ್ಡ್ ಫ್ರಮ್ ದ ಡಿ ಅಂಡ್ ಎಫ್ block elements. So concentrate on the D and F block elements. Next chapter is coordination compounds. So coordination compounds indanu bala important questions keltare. Most probably 5 marks questions are fixed on this. Andre na solution chapter mele helidella 5 marks questions numerical problem keltananta. Same ade tara coordination compounds melenu bala types of questions 5 marks bala ಜಾಸ್ತಿ ಬೀಳುತ್ತೆ, 3 marks questions ಬೀಳುತ್ತೆ. So concentrate, because ನೀವು model question papers ನೋಡಿರಬೇಕು. Now I will solve the model question papers also for you people when the exams will come nearer to you people, so that it will be easy for you people. Okay. Yes, using the crystal field theory, explain the color of TiH2O6 3+ and complex. They have told to explain the TiH2O6 3+. So Ti3+ is actually what? D1. It's a D1 octahedral field. D orbital split into the T2G. T2G ge spread agutte, and example we can give it as what? Absorption of visible light promotes the T2G to EG, that is delta is going to be 0, and the transmitted, whatever it is got transmitted there, okay, that transmitted complementary color is observed, that is purple or violet. That is what we can tell it. Okay. Next, illustrates the influence of the ligand on color in NiH2O6 2+ complex. So if in case color depends on the delta knot placing the H2O by the stronger field ligands, then what we can take the example, if in case NH3 is getting reacted with cyanide, that is Cn. Okay, then what happens? It will start increasing. If it starts increasing, the shifting absorption to the higher energy and the altering the observed color accordingly. Next one, write any 3 limitations of valence bond theory. Like we can tell it as what? It does not quantify color or spectra, struggles with the magnetic movements or exact struggles with magnetic movements, or extract the CFSE and the high or low spin prediction. High or low spin prediction is going to happen, and cannot explain the thermodynamic trends like ligand field stabilizing the energies across the series. Clear? So this is what they will ask a lot of questions on this. This question has been also repeated, guys. Make sure to practice it. How many square pyramidal units are present in decarbonyl dimagnesium 0, and write the formula and structure for decarbonyl dimagnesium. This is also important. Okay, make sure to learn this properly. This question is very, very important, guys. Okay, so this formula, whatever is there, formula Mn2CO10, each MnCO5 is actually approximately trigonal bipyramidal, but often depicted as two square pyramidal, and MnCO5 units is joined to Mn bond. This MnCO5 bond which is present, that will be joined in the form of Mn bond. This Mn, okay, joined in the form of Mn bond. Thus the two square pyramidal units are going to be formed. This way the units will be formed. Means what? Mn bonds will be happening with MnCO5. Clear? Next, write the formula and the structure of the octahedral dicobalt and how many bridged carbonyl ligands are present in it. How many bridged carbonyl compounds are present in it? What we can give the formula now? This is the formula, CO2CO8, and this structure contains how many? 2CO, CaCO4, and the fragments with how much? CO bond. Fragments are going to form with what? CO bonds, and this 2 CO ligands are bridged in between in the common bridging isomer. It is bridged in between the common bridging isomer. Such questions also will be asked. ಏನಪ್ಪ ಕೇಳ್ತಾರೆ, ಈಗ ನೋಡು ಫಾರ್ಮುಲಾ ಬರಿಬೇಕು, ಅದು ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ ಕಾರ್ಬೋನಿಲ್ ಬಗ್ಗೆ ತೆಗಿಬೇಕು, ಆಮೇಲೆ ಅದರದ್ದು ಎಷ್ಟಪ್ಪ ಬ್ರಿಡ್ಜ್ಡ್ ಕಾರ್ಬೋನಿಲ್ ಲಿಗೆನ್ಸ್ ಇದೆ. ಸೊ ಸ್ಟ್ರಕ್ಚರ್ ತೆಗೆದು ನೀವು ಸ್ಟ್ರಕ್ಚರ್ ತೆಗೆದ ತಕ್ಷಣ ಯಾವ ತರ ಬ್ರಿಡ್ಜ್ಡ್ ಕಾರ್ಬೋನಿಲ್ಸ್ ಇದೆ ಆ ಬ್ರಿಡ್ಜ್ ಕೌಂಟ್ ಮಾಡಿ ಅದನ್ನ ಬರಿಬೇಕು ಸೆಪರೇಟ್ ಆಗಿ. ಆಯ್ತಾ ma'am? Numericals, yes, I'll give the numericals, don't worry. I'll make the separate video for the numericals itself. ಯಾವ್ಯಾವ ಚಾಪ್ಟರ್ಸ್ ಮೇಲೆ ಯಾವ್ಯಾವ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ ಅಲ್ಲ ಅವನು ಮಾಡ್ತಾನೆ. ಆಯ್ತಾ? With the help of the structure, explain the sigmatic effect in metal carbonyls. How does it affect MCO bond strength in such of the compounds? If in case sigma donation from the CO lone pair to the metal is complemented by pi back donation. ಈ ಸಿಗ್ಮಾ ಡೊನೇಷನ್ CO ಲೋನ್ ಪೇರ್ ಇಂದ ಡೈರೆಕ್ಟ್ಲಿ ಪೈ ಬ್ಯಾಕ್ ಡೊನೇಷನ್ ಗೆ ಹೋದ್ರೆ ಏನಪ್ಪ ಆಗುತ್ತೆ, ಇಲ್ಲಿ ಬ್ಯಾಕ್ ಡೊನೇಷನ್ ಹೋದ್ರೆ ಫ್ರಮ್ ಫಿಲ್ಡ್ ಟು ಮೆಟಲ್ ಡಿ-ಪೈ ಟು CO bi-star orbits, and this synergic bonding which is happening, that strength which strengthens the MC bond and it weakens the CO bonds, which is lowering what? CO in IR, which is lowering what? CO in IR. Clear? Next question. Write the structure of EDTA 4 minus ion. Explain the how Na4. This is very important, guys. Most repeated question. Aita. Write the structure of EDTA 4 minus ion and explain how the Na4 EDTA is being used to estimate the hardness of the water by the simple titration method. How it will be done? Tell in Kannada, ma'am, please. ಕನ್ನಡನ ಯಾವ ತರ ಕನ್ನಡ ಹೇಳಬೇಕು? ವರ್ಡ್ಸ್ನು ಕನ್ನಡ ಹೇಳಬೇಕಾ? ಯಾವ ತರ ಕನ್ನಡ ಹೇಳಿ ನೋಡೋಣ. ಕಮಾನ್ ಟೆಲ್ ಮೀ, ಯಾವ ತರ ಹೇಳಿ? ಕಮಾನ್ ಟೆಲ್ ಮೀ. Tell in Kannada, ma'am, please. Okay, I'll tell in Kannada now. Okay. So EDTA 4 minus is what? Hexadentate with 2 amine nitrogen and 4 carboxylate 0 donors. Oxygen donors. ಎಷ್ಟಪ್ಪ ಡೋನರ್ಸ್ ಇದ್ದಾರೆ ಅದನ್ನ ನೋಡ್ಕೋಬೇಕು ನಾವು ಸರಿಯಾಗಿ. ಓಕೆ, EDTA 4 minus ಕೇಳಿದಾರೆ ಫಸ್ಟ್ ಅಯಾನ್ದು. ಸೊ ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಅ hexadentate with 2 amine N and 4 carboxylate O donors. O donors ಅಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಡೋನರ್ಸ್ ಜಾಸ್ತಿ ಇದೆ. ಆಯ್ತಾ? ಸೊ ಫಾರ್ಮಿಂಗ್ ವಾಟ್? ಚಿಲೇಟ್ ರಿಂಗ್ಸ್. ಇಟ್ ಇಸ್ ಫಾರ್ಮಿಂಗ್ ವಾಟ್? ಚಿಲೇಟ್ ರಿಮ್ಸ್ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ. ಇನ್ನು ಕಾಂಪ್ಲೆಕ್ಸಿಮೆಟ್ರಿಕ್ ಟೈಟ್ರೇಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ತರ ಆಗುತ್ತಂದ್ರೆ ಆಲ್ವೇಸ್ ದ pH will be 10. ಓಕೆ ಪಿ ಎಚ್ 10 ಇರಬೇಕು ಯಾವಾಗ ನಾವು ಟೈಟ್ರೇಷನ್ ಮಾಡ್ತಿದ್ದೇವೆ. ಓಕೆ ಅವ್ರು ಟೈಟ್ರೇಷನ್ ಇಂದಾನೆ ಹೇಳಿದ್ದಾರೆ ಬೈ ದ ಟೈಟ್ರೇಷನ್ ಮೆಥಡ್ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. ಟೈಟ್ರೇಷನ್ ಮೆಥಡ್ ಅಂದ್ರೆ ಆ ಟೈಟ್ರೇಷನ್ ಮೆಥಡ್ ಬಗ್ಗೆನೇ ಆನ್ಸರ್ ಬರೀಬೇಕು. ಓಕೆ ಇಲ್ಲೂ ಬೇರೆ ಮೆಥಡ್ನು ಇದೆ, ಆ EDTAಗೂ ಬೇರೆ ಮೆಥಡ್ನು ಇದೆ, ಬಟ್ ದೇ ಹ್ಯಾವ್ ಆಸ್ಕ್ಡ್ ಫಾರ್ ವಾಟ್ ಟೈಟ್ರೇಷನ್ಗೆ. ಅದಕ್ಕೆ ಕಂಪಲ್ಸರಿ ಚೆನ್ನಾಗಿ ಕ್ವಶನ್ ಕಂಪ್ಲೀಟ್ಲಿ ಓದಿ. ಸೊ ಕಂಪ್ಲೀಟ್ಲಿ ಕ್ವಶನ್ ಆಗಿ ಓದ್ರೇನೆ ನಿಮ್ಗೆ ಆನ್ಸರ್ ಬರ್ಲಿಕ್ಕೆ ಬರೋದು. ಅರ್ಧ ಓದಿ EDTA ಅಂದ ತಕ್ಷಣ ನೀವು ಎಲ್ಲರಿಗೂ ಒಂದೇ ಇಕ್ವೇಶನ್ ನೆನಪು ಬರೋದು, ಒಂದೇ ಇಕ್ವೇಶನ್ ಬರಬೇಡಿ. ಟೈಟ್ರೇಷನ್ ಮೆಥಡ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ, ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ ಆಯ್ತಾ. ಸೊ EDTA and with aerochromic black T indicator, and this EDTA will bind with Ca2 plus to Mg2 plus, which will qualitatively the volume at end point, which will give the total hardness as CaCO3 equivalence. CaCO3 equivalence. Clear? This YouTube channel is not best for UPSC, and I did not know your language. I know only Hindi. You know only Hindi? Don't worry, I am not teaching in Hindi, I am teaching in Kannada. Okay. Next question, using VBT, explain the hybridization, magnetic property and the shape of NiCN4 2 minus complexes. So CN is what? Stronger filled. Okay, CN is actually, cyanide is going to be the strong filled. If in case we are taking yavadadru now Ni2 plus tagondre adu D8, which will undergo what? Which hybridization? DsP2 hybridization ge hogutteve. So aa DsP2 hybridization hogida takshana yav form agutte, yav type of structure? Square planar complex structure is being formed. Square planar complex structure is being formed. Na 2 marks kalsot ಮುಂದೆ ನಿಮಗೆ ಹೇಳಿದ್ದೆ ಒಂದು ಹೈಬ್ರಿಡೈಸೇಷನ್ ಪ್ರಕಾರ ನೀವು ಜಾಮಿಟ್ರಿ ಎಲ್ಲ ನೆನಪಿಟ್ಕೋಬೇಕು. ಒಂದು ಬಾಕ್ಸ್ ಅದ NCERT ನಲ್ಲಿ, ಅದನ್ನ ಚೆನ್ನಾಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಈಸಿ ಆಗುತ್ತೆ ನಿಮಗೆ. ಹೈಬ್ರಿಡೈಸೇಷನ್ ಗೊತ್ತಾದ ತಕ್ಷಣ ನೀವು ಸ್ಟ್ರಕ್ಚರ್ ಡೈರೆಕ್ಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಫೈಂಡ್ ಮಾಡ್ಕೋಬಹುದು ಆಯ್ತಾ. Next one is what? Draw the energy level diagram, crystal field splitting in the octahedral complex. What is the spectrochemical series? So this also people can answer it. This is also very important question. Okay. ಒಂದ್ಸಲ ಡ್ರಾ ಇದನ್ನು ಆಕ್ಚುಲಿ 3 marks ಕೇಳ್ಬೋದು, 5 marks ಕ್ವಶನ್ ಅನ್ನು ಕೇಳ್ಬೋದು. ಸೊ ಮೇಕ್ ಶೋರ್ ಟು ಲರ್ನ್ ಇಟ್ ಪ್ರಾಪರ್ಲಿ. ಓಕೆ next one, based on the crystal field theory, write the configuration for the metal with d5 electron. With how much? What is actually d5 electron system when delta naught is less than P and delta naught is greater than P. Next one is what is the pairing energy? What is the pairing energy? 2 questions they have asked it. Such questions they will ask it A ಮತ್ತೆ B, because 1 marks ಒಂದಿರುತ್ತೆ, ಒಂದು ಸಿಂಗಲ್ ವರ್ಡ್ ಇರುತ್ತೆ, ಅದ ಆನ್ಸರ್ಗೂ 1 marks ಕೇಳ್ತಾರೆ, ಇನ್ನೊಂದು ನಿಮಗೆ B ಕೇಳ್ತಾರೆ, ಅದು 2 marks ಇರುತ್ತೆ. ಆ ತರನು ಕ್ವಶನ್ಸ್ ಕೇಳಬಹುದು ಆಯ್ತಾ. ಫಸ್ಟ್ ಒನ್ ಹೇಳಿದರೆ ಡೆಲ್ಟಾ ನಾಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಲೆಸ್ ದೆನ್ P, and ಸೆಕೆಂಡ್ ಒನ್ ಇಸ್ ವಾಟ್? ಡೆಲ್ಟಾ ನಾಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಗ್ರೇಟರ್ ದೆನ್ P. ಫಸ್ಟ್ ಒನ್ ಏನಾಗುತ್ತೆ, ಇನ್ octahedral field, if in case it is less than, the high spin T2G Eg2 5 unpaired when delta naught is less than pairing energy. If in case we are taking a lowering spin, okay, if in case we are taking a lower spin T2G EGO, that is 1 unpaired electron when delta naught is greater than P. Okay, delta naught is greater than P. Okay, next one, Beat one. Next question, what is pairing energy? What is the pairing energy? So P is the energy which is required to pair 2 electrons, which is required to pair the 2 electrons from the same compound or different compound in the same orbital, overcoming inter-electronic repulsion. In the same orbit, interrelation, electron repulsion anta kaidire gotta, adu same orbital aguttalla, same ade tara. Okay, same ade tara reaction agutte. Clear? Understood everyone? Yes. Next question. Haloalkanes ಮತ್ತೆ haloarenes chapter ಇಂದ, I think haloalkanes haloarenes chapter ಅದಾದ ತಕ್ಷಣ ನಮ್ದು ಆಲ್ಕೋಹಾಲ್ಸ್ ಮತ್ತೆ ಫಿನಾಲ್ಸ್ ಉಳಿಯುತ್ತೆ ಆಯ್ತಾ. haloalkanes and haloarenes ಇಂದ first one question, write the steps which are involved in the mechanism of conversion of 2-chloro-2-methyl butane into 2-methyl butane, that is 2-OL. So they have told to write the steps or a mechanism to be conversion of this compound into the 2-OL, means 2-methyl to 1-butane OL. Okay, which type of solvent favors such reaction? Which type of a solvent is forming the such Friel कंपाउंड जिसमें एक सेंट्रल एटम मेटल एटम के आसपास लिगेंड्स जोड़कर एक स्टेबल कॉम्प्लेक्स करते हैं. Example Cu plus. Yes, yes, good. That's good. So what happens here? SN1 mechanism. So SN1 mechanism mein what will happen? There the ionization. So ionization ಏನಾಗುತ್ತಲ್ಲ ಅದು tertiary carbocation ಈ ತರ ionization form ಆಗುತ್ತೆ. If in case we are taking the 2-chloro 2-methyl 1-butane into the we are converting that to 2-methyl 1-butane 2-OL. Okay, convert ಮಾಡೋದು ಅಲ್ಲಿ OL ನಲ್ಲಿ. Okay, ಅವಾಗ ಏನು ಮಾಡುತ್ತೇವೆ ionization to that entropy tertiary carbocation ಇಲ್ಲಿ CH3 CCl 3C ಕ್ಲೋರೈಡ್ ಇಲ್ಲಿಂದ ರಿಯಾಕ್ಟ್ ಆಗಿ CH3 ನೋಡಿ CH3 3C plus okay Cl minus. This is how the reaction is going to be forming. If in case we are taking the which type of a solvent solution, if in case that they have asked, then nucleophilic attack by H2O is going to form, that is tetrabutyl oxamin is going to be forming. Then deprotonation is going to be what? Tetrabutyl alcohol, which is flavored by fluoroprotic solvents like a water or ethanol. We can use it. Okay. Next, write the steps which are involved in mechanism of conversion of ethyl chloride to the ethanol. What order of kinetics it is been following? If in case it is the S2 pathway, okay, S2 pathway, then backside attack by OH minus on CH3 CH2 Cl with one step transition. S2 andre SN2 andre eno one step transition state to give what is the product we are going to get? That is CH3 CH2OH plus chloride. CH3 CH2OH plus chloride. One step process. So idana product form agi agutte. Next, bimolecular rate is actually equal to what? KETCl OH minus, which is going to be the second order. This is also important question, guys. Important question. Write any 3 reasons why the haloarenes are least reactive towards the nucleophilic reaction. So this CX is actually aryl halides in strengthened by partial double bond, which is due to the resonance. Which is due to the what? Resonance. Which is forming the resonance, and this sp2 carbon will hold the substituent more strongly, and it is the hydrous backside attack. It will hydrous from the backside attack. Backside in the attack agate SN2 nalli. Okay. ಆಮೇಲೆ ಅದಾದ ತಕ್ಷಣ sp2 carbon holds the substituent more strongly and hasides from the backside attack, and the nucleophile, whatever the nucleophile is present, must approach an electron rich ring which is facing the repulsion and a poor leaving group stabilization. Theta. So idu question bada important, guys. This is also too much important. Okay, mala sala repeat akiro question. Write the resonating structures. Explain why the chloride directs electrophile towards the ortho and para position. So, nodi ortho matte para position in the haloarenes. So, in the haloarenes, despite the electron withdrawing nature is present, even then it is happening. Okay. So, enaguttali withdrawal, almost one electron withdrawal inductivity, but a lone pair resonance donates. Lone pair resonance will start donating to the ring. Okay, that is going to be what? Plus M. That is going to be the plus M. So this is creating what? P electron density, which is creating the P electron density, which the resonance structure is going to be place the negative charge at how much? OP carbons, which is going with OP direction to the deactivating behavior. We act with the deactivating behavior. Clear? Next question. Illustrate the Jytsev rule with an example. This is also very important, guys. Most asked question. Okay. Yes. So what is that? In Bella elimination, the more substituted alkene predominates. Then what is going to be the example? 2-bromo-butane plus alcohol KOH, which is going to form what? Major 2-butane minor and 1-butene which is going to be forming. Clear? Next question, primary alkyl halide, that is C4H9Br. C4H9Br ge with, in case primary alkyl halide with alcoholic KOH, which will give what? With HBr gives what? Then afterwards, which is an isomer of A, and write the structure of an A, B and C. They have told it. So what will be if in case with alcoholic KOH? If in case it is with alcoholic KOH, it will be what? 1-bromobutane. It is going to form what? 1-bromobutane. If in case 1-butane, then it is going to be the elimination process. That process is called as what? Elimination. Okay. Last one with which is an isomer, they have asked it. Okay. So 2-bromobutane, which is going to be the Marcanus addition and isomer of an A. This is the isomer of an A. This is going to be the answer. This is also most asked question. Bala sala keliro question. Okay. Next one. Compound M, that is C3H6 on reaction with HBr, which will form N on heating with Na in dry ether. N produces hydrocarbon X with IUPAC names of M, N and X. How it's going to be forming? Science and technology, miss. Okay. Compound M, that is C3H6 on reaction with the HBr forms N. On heating with Na, dry ether, N reduces hydrocarbon X. Write the IUPAC name of M, N and X. This is how it's going to form. This is M means what? Propane. Propene is going to form. M is going to be what? Propene. I'll write it if you people are, it's not visible properly then. N means what? Propene. Okay. How it's going to form the reaction here? CH3, CH2 plus HBr, which is going to form what? CH3, CHBr, CH3. So, M ಏನಾಗುತ್ತೆ? This is going to be the propene. Okay, it's going to be the propene. So what will be the N? That is going to be the T-bromopropane. Propane. Okay, T-bromopropane. Clear? It's visible now properly? Yes. This is how the reaction is going to form. Now define the following, that is Rangnick mixture, that is enantiomers, and the last one is what? Optical isomers. These are the definitions which they will ask it a lot of times. Make sure to practice these also. Okay, next one. Complete the reaction sequence, that is C6H6 plus Br2, which is forming BSE-Br3, that is Y and Y. They have told us to find all the things. Means they have given all the things that we need to find it. This is the structure which we are going to get it. So, structure ಹೇಗೆ form ಆಗುತ್ತೆ ಹೇಳ್ತೇನೆ ನೋಡಿ. Okay, how it will be, the structure will be formed. Benzene, which is present. You can concentrate your benzene properly. Benzene ಹೇಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ. Okay, plus Br2 in the presence of FeBr, it's going to be forming Br. This is why. That is bromobenzene. Okay, bromobenzene in the presence of Mg or dry ether. This is how the reaction is gonna be forming. Okay, in the presence of RNH2. This is Z, this is MgBr. Okay, this will be what? Penyl magnesium bromide. This will be what? Penyl magnesium bromide, and that is the benzene. I'll write it in the different color here. This will be what? Here. This will be what? Penyl magnesium bromide. ಫಿನೈಲ್ ಮ್ಯಾಗ್ನೀಸಿಯಂ ಬ್ರೋಮೈಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ಇಲ್ಲಿ ಬೆನ್ಝೀನ್ ಅನ್ನ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. Here it will be formed what? Benzene will be formed. Clear everyone? Clear? Yes. Next one. Alcohols, phenols and ether. Last chapter idu bala important questions illinu bೀಳುತ್ತೆ. Yes. So what are the primary, secondary and tertiary alcohols? They have told us to explain the primary, secondary ಮತ್ತು tertiary alcohol ನ explain ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. This is also important guys. Make sure to learn it. Primary have CH2OH attached. CH2OH which is attached to the one not carbon, that is going to be this general equation, okay? RCH2OH. This is a general equation. Secondary nalli enaguttappa? Secondary nalli CHOH which is attached to the 2 degree carbon, that is CHOH R2 R1 ಇದು R1 CHOH ಗೆ ಅಟ್ಯಾಕ್ ಆಗಿ R2 ಅನ್ನ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ನೀವು ಯಾವುದು ತಗೋಬಹುದು R1 ಮತ್ತೆ R2 ಪ್ಲೇಸ್ ನಲ್ಲಿ, ಓಕೆ? Tertiary have what? COH which is attached to 3 degree carbon with the 3 alkalis, that is R3COH. R3COH. So next question is what? Write the mechanism involved in the acid catalyzed hydration of propene. Okay, propene the acid hydrolyzed catalyst ಇರಬೇಕು. Electrophilic addition with the mycoic path, that is protonation of gives what? Secondary carbocation, which will give what? Secondary carbocation form ಆಗುತ್ತೆ. Secondary carbocation will be formed. Now that CH3CH plus CH3 is going to be forming. This will be the equation which will form here. Okay. Next ಏನಾಗುತ್ತೆ? Water attack forms oxonium. And third one is what? Deprotonation is propane 2OL. Propane 2OL ಅನ್ನ form ಆಗುತ್ತೆ. Yes, very good. Yes, correct. Next, explain the preparation of phenol from cumene. Write the chemical equation. So cumene, this is also important guys. Okay. So cumene is oxidized to cumene hydroperoxide, then the acid cleaved to the phenol and acetone. So for that purpose, this C6H5 which is going to react with CH3 twice, 2, okay? That will be forming what? C6H5C CH3 2OOH, and this C6H5OH plus CH3 2CO, which is going to form what? 2CO. This is also important, okay? Next, explain the preparation of phenol from aniline. Phenol from aniline, and write the chemical equation. So diazotization followed by the hydrolysis, that is going to be what? C6H5NH2 plus HNONO2 divided by HCl, that is from the degree 0 to 5 degrees Celsius, C6H5N2 plus Cl minus, then the warm with the water or Cu2 plus, or C6H5OH plus N2 is going to be forming. Clear? K2Cr2O7 please. K2Cr2O7 please. What K2Cr2O7 please? Okay, what is the effect of electron withdrawing group on acidity of the phenols? So electron donating group on acidity of the phenol, actually first one withdrawing go, amele donating, okay? See, here they have asked electron withdrawing, here electron donating group. So that is what we should write. If in case they have asked for the withdrawing, that will have groups increasing acidity by the stabilizing the penoxide. Second one is what? If in case electron donating agutte, avag plus M groups decrease agutte acidity nalli by the destabilizing penoxide. And third one is what? Boiling, increasing carbon number of the boiling point of the alcohols anta kelidare, okay? So illi enagutte? Boiling point will rise with the chain length due to the higher van der Waals forces. This is going to be the reaction. Now next one is what? Write the mechanism of acid catalyzed dehydration of ethanol to ethene. Okay, illu E1 E2 under concentration of H2SO4 and at the temperature of almost 413 Kelvin, if we are taking it, that protonation of that OH to OH2 plus, OH in the OH2 plus ge convert agutte, okay? So avaga E1 E2 undergoing the concentration, okay? So second one in kelidare, that is loss of the water to form the carbocation. Then the beta elimination of the H plus is going to be forming. Can't understand K2Cr2O7. Enu complete question keli. Next, mention the products obtained when the vapors of primary, secondary and tertiary alcohols are passed over heated copper at 573 Kelvin. 573 Kelvin. This is very important, guys. Most asked question. Okay. Primary aldehydes, that is dehydrogenation. Example, HCH2OH or RCHO plus H2 if they are taking it. Okay. Avaginagutte secondary, that ketone, that is R1CHOH R2 and R1CO R2, that is H2. That is tertiary is alkenes by dehydration. Alkenes by dehydration. Yes, very good, Mohammed. This is how it's going to be forming. Next question, what happens when the vapors of primary, secondary and tertiary alcohols are passed over the heated copper at 573 Kelvin? Write the chemical equation for the each one. Okay, for the each class. For as the above equation, we can write in this way the equation for those things. Ma'am, I want all the 4 subjects important questions to target. Yes, we are giving you important questions. You need to be attentive in the class, then only you will have an idea that how they are giving it. Already 2 marks questions is done. Then now I am doing the 3 marks questions. We will be doing with the numerical problems also and 5 marks questions also. So make sure you people will practice them properly. Okay. Next, give the details of 2 commercially important alcohol. What is the denaturalization of alcohol? Denaturalization of an alcohol. Ethanol is widely used as a solvent or a fuel, and beverages, whatever this there, that is methanol has a solvent or antifreeze and the feedstock. So for that purpose, denaturalization, that is adding the toxic or the substances, toxicity or the substances. Like sometimes we will have a soda that some sort of a sound will come, right? So that type of things. Example, methanol, parenite to ethanol to the make it unfit for the drinking. So this all are unfit for the drinking. Why? Because they'll create a soda. They'll create a buzz in our stomach. Next, how to prepare an aspirin from the salicylic acid? Write the chemical equation and deduce the IUPAC. Name has the aspirin. This is very important, guys. Most asked question. So esterification of a salicylic acid with the acetic anhydride, which will give aspirin and the acetic acid. The reaction also they have given it, that is C7H6O3 is getting reacted with CH3CO2O to form what? C9H8O4 plus CH3COOH. The IUPAC name also they have asked it in the question. You can just observe here. Of an aspirin, that is 2-acid oxybenzonic acid. 2-acid oxybenzoic acid. Okay, that is also called as what? Acetyl salicylic acid. Acetyl salicylic acid. That is also called as. Yes, PDF is available, Ramesh. You can go and check it in the Telegram group. Okay. So this is how the answer is going to be forming. So these are all the questions of a 3 marks questions. These all are for the 3 marks. Make sure you people will practice it. 3 marks question bala kadame compared to the 2 marks questions. Okay. Nimagon more model question people solve martane. You'll have an idea about how the questions will be asked in the part A, part B till part E. Okay, part E. मेरी तरह हिंदी मीडियम वाला है कहाँ? Okay. So you people need to practice the 2 marks and the 3 marks questions properly. Yakandre 2 marks ಮತ್ತೆ 3 marks questions ಅಲ್ಲಿ difficult ಆಗೋದು. Okay, 5 marks questions ನಲ್ಲಿ numerical ಸ್ವಲ್ಪ difficult ಆಗ್ಬೋದು. ಅದನ್ನ ಬಿಟ್ಟು ಡೈರೆಕ್ಟ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಕೇಳಿದ್ರೆ ಆರಾಮಾಗಿ ಆನ್ಸರ್ ಮಾಡ್ಬೋದು ನೀವು, ಬಿಕಾಸ್ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ ಯಾವ ತರ ರಿಪೀಟ್ ಆಗಿರಬಹುದು ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನೋದು. ಓಕೆ, 2 marks 3 marks ನಲ್ಲಿ ಸ್ವಲ್ಪ ಸೈಕಲ್ ವೈಸ್ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ. ಒಂದ್ಸಲ ರಿಪೀಟ್ ಆಗುತ್ತೆ, ಒಂದ್ಸಲ ರಿಪೀಟ್ ಆಗಲ್ಲ. ಬಟ್ ಐ ಹ್ಯಾವ್ ಗಿವನ್ ಯು ಪೀಪಲ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಕ್ವೆಶ್ಚನ್ಸ್ ವಿಚ್ ಹಸ್ ಬೀನ್ ರಿಪೀಟೆಡ್ and which has been asked a lot of times in the model question papers also. So make sure you people will study this 3 marks questions properly, each and every question. I have given the answer also. PDF will be available for you people in the Telegram. Make sure to learn it properly so that it will be useful to you people. Okay, and don't waste your time. Midterms are coming soon, so make sure to learn and use your time accordingly so that it will be really be helpful. Okay, till then, see you everyone. Bye bye.